Good evening, it's M Squared here. Today we are going to work on my notes for Chapter 1, and these are just some words that you need to be aware of, what their meanings are, so that when we have class on Zoom, you already have these notes filled out. So that is your goal, is to fill these notes out. So I'm hoping that you recognize some of these words. Remember, this is preparation to solve linear equations, which are our next two learning targets, solving equations with x on one side or a variable on one side, and solving linear equations with variables on both sides. So we probably want to know what a variable is. I'm hoping you remember that a variable is a letter, and it represents a number, and our goal is to figure out what number that the letter represents. So variables, for the most part, will be x, y, that kind of thing. So those will be some examples. Examples over here, an x, a y, a z, those are variables. A constant is a number. So if you just see the number 2 all by itself, or the number -1/2 all by itself, we're going to call those constants. If you see an x with them, then that's something different. That's the one I put way down here at the bottom, so we're going to talk about that. A coefficient, sometimes when you see a number, it is not considered a number, it's considered a coefficient. So this is the number part, or we should say number part, it's the number that's multiplied by a variable. So a coefficient, for example, in the term 5x, the coefficient is the 5. So if you have -1/2 y, the coefficient is the -1/2. So these are both coefficients. So sometimes when you see a number, it's not considered a constant. It's considered a coefficient. All right. Equivalent. Equivalent, we're just going to remember, means equal to, the same as. So when you write an equation, right, it's a number or variable expression with an equal sign. This is the important part. It's not an equation if it doesn't have an equal sign. So two expressions are equivalent on either side of the equation. So for example, if I have 5x plus 3 equals 17, then I would know, because of that equation, because of the equal sign, that 5x plus 3 is equivalent to 17. When I'm solving, I'm trying to find the value of x that would make these two equal. Okay, linear, you see the first 4 letters means line. So when you see the word linear, I want you to think about lines. So we're solving linear equations. That means they don't have any exponents like x squareds or anything like that. It's just going to have an x. It's going to have one variable. So how you tell if it's a linear equation is it just has one variable. But we're going to do lots of things with linear equations and functions. So we're going to solve them. We're going to graph them. We're going to write equations from word problems. We're going to write equations from lines. So there's lots we do, but whenever you see the word linear, I want you to think line. Inverse operations, opposite operations. Opposite, we're going to say inverse is kind of like opposite. So if I said operation over here, and then I said the opposite operation over here, that's operation. So if I said addition, you would say, oh, the opposite of addition is subtraction. The opposite of multiplication is division. And then it goes backwards too. The opposite of division is multiplication. The opposite of subtraction is addition. So in order to solve linear equations, you need to know what the inverse operation is, or what the opposite operation is, to get rid of those things. Okay, the word isolate, I'm going to say isolate the variable, or isolate the constants. So you need to know that isolate means get alone, and I'm referring to on one side of the equation. All right. Solutions. Solution of an equation. That is the value, and that's a numeric value, it's going to be a number, until we do bivariate equations. But for most part, it's going to be a value that makes the equation true. So, for example, if I said 2x equals 10, the solution to that is the value of x that makes it true. So since 2 is being multiplied by x, I could divide both sides by 2 to undo the multiplication. Those are my inverse operations, so that I get x equals 5. So does 2 times 5, if x was 5, equal 10? Yes. And in a linear equation, and with the variable on one side, there will only be one answer. As you learn different types of equations, you'll learn that sometimes there's more than one answer to a solution, to an equation, more than one solution. But for our purposes, there'll just be one. So it's whatever value makes the equation true. Distributive property, and we've talked a little bit about that in class, is when you distribute. So let me give you a number example, and then I'll give you another example. Distributive property. If I said 3 times 17, and I'm thinking, I don't know what 3 times 17 is, I can split the 17 up. I can say, oh, well, 10 plus 7 is the same as 17, and I know that 3 times 10 is 30, and I know that 3 times 7 is 21, so 21 plus 30 is 51. That's using the distributive property. When I take and split something up, and then I distribute the outside part that's being multiplied by it by both things. So an example of that in algebraic terms would be something like this. 5 times, in parentheses, 2x plus 3. So I've got to take that 5 and multiply it by both things. So 5 times 2x is 10x. 5 times 3 is 15. So distributive property is used to either simplify expressions, and sometimes we go backwards, and that's called factoring, and we'll learn about that later. So it's used kind of both ways. And combining like terms. So it would be important that you know that like terms have the same variable expression, the same variable part. Let's say part. So 3x and 7x are like terms, and if I put a plus sign in the middle, then we could say 10x. But if I say 3x plus 7y, those are not like terms, so that would be the answer. So you have to remember, when you combine them like terms, that it's sometimes not possible because there aren't any like terms. So we want to make sure you remember what like terms are. Okay, so real quick then, I want to show you, I make this, especially for kids that have a hard time knowing what to do when they solve an equation, I wrote these steps down. This is page 8, but on page 9, it's kind of like a flow chart. So you do this first, then you do this, then you do this, then you do this. Just kind of like that, if you like that kind of method better. But over here, it's just the steps. So the first thing you should always do is ask yourself, hey, in this expression, are there any fractions? And then if there aren't any fractions, then you go to the next step. If there are, you eliminate them by multiplying each side with a common denominator. And then, are there any parentheses? If there are, you use distributive property to get rid of the parentheses. Watch out for negatives. And then, after you finish that, you combine like terms on each side. You don't combine terms on opposite sides because you have to move stuff from side to side. But on each side, you can combine like terms. Then isolate the variable. That means get all the variables on the same side, and you do that by adding or subtracting that x term. And then isolate the constant. Get all the constants. Remember, those are the numbers without being multiplied by x's or variables. You get all of them on one side the same way by adding or subtracting. You do the opposite of whatever's happening. The almost last step is to eliminate the coefficients, and you do that by doing the opposite. A coefficient is multiplied by an x, so you're going to divide, and then check your solution. This just makes you confident that you're correct. So those are the steps, and part of your homework is going to be not to solve these, but to say what you would do first, referring to these steps up here. So for example, if I don't see any fractions here, I'm not going to say eliminate fractions. But I do see parentheses, so what would you do to get rid of the parentheses? So you have to say what step you would be at for each of these. And that's going to be your homework. Okay? So good luck with that, and then we'll talk about the rest in class. M squared, signing out.